hi, welcome. My name is Oli Griffiths, and I'm going to teach you about how Broccoli works and how to build your own Broccoli pipeline. So let's get started. So what is Broccoli? Broccoli.js is an asset pipeline for ambitious web applications. Okay, cool. So you want to build an ambitious web application. Well, what does that mean? Sounds kind of scary, right? I just want to make a simple JavaScript application with ES6 transpilation, CSS, preprocessing, asset concatenation, live reload, uglification, vendor and NPM module inclusion, development server. Oh wait, perhaps that's ambitious. So Broccoli.js is a file system abstraction for transformations of input files into output files. That is all it is. It is at its core just files coming in and files going out. Internally, Broccoli represents transformations as what they call nodes and plugins, and it uses these to build up a graph in memory. Broccoli handles connecting these nodes and plugins together and handles passing files in and out of each plugin. So here's a glossary. What is a node? So a node is like a snapshot of the file system with inputs and outputs. A node can have multiple inputs and it has a single output. So it's starting to sound like a little bit like a tree. Now, plugins process nodes and they emit files into an output directory. And plugins are where the actual work happens. So when you're transforming your CSS from Sass into CSS files or your JavaScript from ES6 modules into regular common.js format that you might want to use within Node, that's happening within the plugin. And a tree is just a collection of nodes and plugins. So plugins connect nodes together and the whole thing forms a tree. So nodes come in two flavors: source nodes and transformation nodes. Source nodes are a source directory, something that exists within your application. They can be watched and they can be unwatched. And when files change within source nodes, they trigger a rebuild. Transformation nodes, or transform nodes, take a node as an input, they're cacheable, and they're persistable. Now, transform nodes typically make up the majority of your Broccoli pipeline. Source nodes will just be your entry point, maybe your app directory or a source directory or something like that. Plugins, on the other hand, process these nodes and emit files to an output directory. So these are the building blocks of Broccoli, and they perform the actual work. Plugins are the API that userland code typically uses. They accept either source nodes or transform nodes as inputs, and they will typically wrap a node package to do some form of transformation. So think of Babel, for example. The Broccoli Babel plugin is really just wrapping Babel, passing the inputs, and Babel does its processing, and then it writes its output to the plugin's output directory. And Broccoli provides references to the input directories and an output directory. So from the plugin's perspective, it just loops through the inputs, does work on any JavaScript files that it finds on those inputs, and writes the output to the output directory. So a tree is a collection of nodes and plugins, and they represent the full transformation pipeline from your original source node, your entry point, your app directory or source directory or something like that, through plugins into output nodes. And the trees can be created and manipulated by you when you're building your Broccoli pipeline through your Broccoli.js or your EmberCLI build.js. And these are composed and split as you desire. So you can think of a tree much like a directory structure. Ultimate output directory is your dist directory, and then that has gone through various stages all the way from your original input directories through various processing and out into one final output directory. So here's an example pipeline. Say you have a source directory, which is your app directory, and within that you have an app JavaScript file, and that links through, say, an ES6 import statement to foo.js and components bar.js and any other JavaScript files you have. You have an input styles app CSS file. You maybe have a header image, maybe you have a logo, and you've got your HTML file for your application. So this is what it might be typically represented in a Broccoli build pipeline. So first of all, we have our source node. This is our app directory. That is then going to get passed into a plugin. Basically it can be thought of like a glob expression in the terminal, and it's basically a way of finding files within a given directory and passing them out through its output directory. So in our case, we would have three separate filters. one for our JavaScript, one for our static assets like our HTML, our PNG, JPEG files, and one for our Sass file. Then we're going to pass the output of that into Broccoli ESLint and Broccoli SCSS lint to lint our files, make sure that they conform to whatever coding standards you wish to conform to. From there, those files are all going to then be passed down into Broccoli Rollup, for example, if you want to use Rollup to do your ES6 transpilation and your concatenation and bundling, and into Broccoli Sass, which is actually going to do your Sass transforms and manipulate your Sass files into CSS files that can run in the browser. After that, you may then want to run through your Sass and your CSS and your JavaScript files through something like Broccoli Auto Prefixer, which will automatically take vendor unprefixed expressions within your CSS file and make vendor prefixes like the -ms or -webkit prefixes that are needed for certain attributes. And in your Broccoli Babel transpiler, I'm sure you're familiar with Babel, that will convert your JavaScript from stuff that we want to write in the editor into something that will actually run in the browser. After that, a very common plugin is used, which is Broccoli merge trees, and all this is doing is just copying files from one directory, each of the directories, into the final output, and all the files end up in the output directory. And that will ultimately be our dist directory right at the end. So the very last stage of most Broccoli pipelines will be a Broccoli merge trees, where it's merging everything that's happened in all previous steps down into your dist directory. And then you may end up with something that looks like this. You've got your app.js file, which is all of your JavaScript bundled into that one file. You've got your app CSS files, and you've got your assets, your header image, your logo, and your index.html, which have just basically been proxied through from your original application. And so this is what a full tree might look like. This is the full process that I just explained there as a Broccoli pipeline. So hopefully that's given you a bit of an overview of how Broccoli works. Next up, we're going to go and do some live coding, and I'll show you how to build a Broccoli pipeline of your very own. So if we just hop over onto my website here, I've got a Broccoli.js tutorial at oligriffiths.com/Broccoli.js, which runs you through all of the steps, the background that I just went through, and all of the steps to build your own Broccoli pipeline. Let's take the first step. We want to set up our project. But the first thing that we want to do is we're going to want to make a directory. We're going to want to cd into that directory, and we're going to want to initialize our project. So let's go ahead and do this. Okay, so first things we're going to do is we're going to create a directory for our tutorial. Then we're going to cd into our tutorial directory, and we're going to initialize our project just with the default options that Yarn provides, so I don't have to hit enter every time. The next step we want to do is we want to install Broccoli and Broccoli CLI. So Broccoli CLI can be installed either globally or within your project. If it's installed globally, you obviously don't need it in the project, but I like having it in the project because it then keeps everything in sync, and we can execute Broccoli CLI using the Yarn command line options. So our project should be set up here, and we should have our basic project ready to go. Now that Broccoli has been installed and set up, let's go ahead and start developing our application. So let's open VS Code. So now VS Code is open. First thing that we want to do is we want to add some scripts to our package.json, and this will basically just allow us to execute Yarn commands to build our application. We don't have to remember what Broccoli commands to use. We're going to have two commands here, build and serve. If you're familiar with Ember, those will sound very familiar to you. If you've not used Broccoli.js before, what build does is it runs through your build pipeline and writes all the files into an output directory, which defaults to a directory called dist. Serve, on the other hand, starts up a local development server and live loads your application so that you can run it in a browser. If you want to set up interactive debugging in either VS Code or IntelliJ, there are some examples here on how to do that. It's a great way to explore how Broccoli works and debug things if things end up going wrong. I'm going to skip over this for now, but it's in the tutorial if you want to check it out. So after we have set up our scripts, first thing we want to do is we want to create a Broc file. Now, Broc file is just Broccoli parlance for where am I going to put my build configuration. So let's go ahead and create a Broc file. So The entry point to our Broccoli build system is called a Broc file. And this is just Broccoli parlance for, this is where I'm going to put all of my build configuration. We write Broc files in regular JavaScript, so it should be fairly familiar to you if you're familiar with JavaScript. So we're going to create our Broc file in the root of our project, and we're going to add this contents to it. So let's go to our project. We've got our Broc file here, and we're going to export, let's make this go away. We're going to export an app folder. Well, we don't have an app folder yet, so let's go ahead and create that. So let's create an app folder, and let's create an HTML file just with a simple eat your greens. So next up, let's explain what this Broc file is doing. So as I mentioned to begin with, there are two types of nodes. There are source nodes and there are transformation nodes. And source nodes always refer to a directory. What we export from our Broc file is what Broccoli will use to build our full build pipeline. And if we just export a string from this Broc file, Broccoli will turn that into a source node. And at any other time, whenever we do use a string within any of our build pipeline, Broccoli will automatically convert that to a source node for you. You don't need to do anything. So in this very, very simple build pipeline, we're just going to export our app folder. So what we should expect is in our dist folder, once we have built the project, we just have our index.html file written out. That's all that's in there. It's not a great build pipeline, this. We're just copying files from one directory to another, but this explains how we get started. So yarn build. This will build our application. And you can see that Broccoli outputs some information about what it's done, the slowest nodes, to help you debug if something is taking a long time as part of your build. So this is done, completed in 0.7 seconds. And we can look in our dist directory here, and we have our index.html file. So everything looked groovy so far. If we run yarn serve, we'll be able to see what happens when we serve our application. So if we click on this, there we go, we've got our index file, eat your greens, everything is looking super so far. So let's quit out of this and let's move on to the next step. You can walk your way through this tutorial and you'll be able to follow along in exactly the same way. You can go at your own pace. Each step of the tutorial is linked to a GitHub repository with a branch so that if you do get stuck, you can just hose away your directory contents and you can check out that branch and you should be at the same step for every step through the tutorial. So the next step is we're going to add Broccoli funnel. So let's go ahead and install that. All right, perfect. That's installed. Let's go and update our Broc file. So let's copy this and paste this in. So we've made our Broccoli pipeline a little bit more complex now. So we're including the Broccoli funnel package. And I've defined a constant here just to define what our app root is. Because I'm going to use this in a few places, I'm going to keep it as a constant rather than continually having to type out the app string. What we're going to be doing here is we're going to be using funnel to copy our index.html file into our output directory. So this is pretty much doing what we already had done, but if we had other files within our app directory, when we return app as module exports here, if I just do app here, that's going to copy the whole directory across. But we actually only want to copy the single HTML file. So this explains how funnel works. So just to show how this plugin works, as I mentioned previously, if you return a string, say app, from module exports, it's going to copy the full directory into the dist directory. Now we don't want to do that. We want to just copy our index.html file. So let's create another file in here and I can show you how this filter plugin works. Let's put foo in here. Let's do var foo. So the funnel plugin comes with various options and you can look it up on GitHub and see what options you can pass into it. But for our case, we're telling it, okay, we want to include just the index.html file. The destination directory is /, which is actually the default. And we're going to pass it an annotation. Now, annotation is pretty useful. What this allows you to do is Broccoli will store that annotation, this description against each node. So if there are problems, it will print that out with your stack traces and just gives you a bit more debugging so you can find out if you're reusing a plugin multiple times, which different time it was used. So let's go ahead and build this and we can see what happens. Yarn build. Cool. If we look at our dist directory here, we can see we've still got our index.html file, but we don't have our foo.js. So that looks good. let's move on to Broccoli merge trees. So let's get this installed. Great. Now we want to add some directories that we're going to ship various content with our app. You may be familiar with the public directory in ember.js, which is just blindly copied to your output directory. And in our case, we're also going to have some other things like some CSS files and some JavaScript files. So let's go ahead and create these directories. Okay, so we've created two directories here, a public/images directory, an app/styles, and we've just added two files, which is app/styles app.css and app/app.js. Let's go ahead and put some content in these files. So let's add a lovely pale green background to our app. I'm going to preface this with saying I am no designer and this is not going to look good. Let's add some JavaScript to our app.js file. Let's get rid of this foo.js. We don't need that anymore. That was just to show that example. And let's update our index file so that we can reference these new files that we've added to our project. Last but not least, let's copy the Broccoli logo and let's pop it into our images directory. So let's open this. Great. So we've got our image here in our images directory. We want to update our Broc file. So now we're going to be using both funnel and merge together to create our final application. Okay, so much like before, we have our HTML funnel, but now we've also added a JS funnel and a CSS funnel. And this allows us to handpick those specific files and make sure that they get copied to the correct place in the output directory. So in these two cases, we want to just copy them into an assets folder in our dist directory. For the public directory, we're just going to copy everything from the public folder, and that's all going to end up in the output directory. So whatever is in here is going to end up carte blanche, just copied into the output directory. The final line here, now instead of returning the funnel, we're returning merge. Now merge, what this does is takes an array of inputs, so here we've got our 4 different funnels, and it will merge everything into an output directory, whatever its output directory is that's provided by Broccoli. In this case, it will be the dist directory. We're also giving this an annotation that this is the final output, the last thing that we're returning. So let's go ahead and run this and make sure that everything is working as expected. Okay, cool. So now we can see our output has a few more nodes in here. So we've got our final output. This is the annotation that we provided here. We've got our index file, our public files, and our JavaScript files. Now these are all doing the same thing. So really at the moment, this is a pretty quick build pipeline. These are 7, 4, and 2 milliseconds and 0 somehow. It was instant. So let's go and have a look at our output directory and see what we got. So in our output directory, we've got our assets, our CSS, and our JavaScript file. We've got our image, which is here, our Broccoli logo, and we've got our index file. Let's go ahead and run this and see how this looks in the browser. So let's open this. Excellent, this is looking great. And we can see, eat your greens, that's the JavaScript that we had in our JavaScript file. We can see that that's being included correctly. Our CSS is running nicely. We've got this lovely pale green background, and we can see the Broccoli logo here, slap bang in the middle of the screen. So everything is looking good so far. Let's get back to it. So you're probably using some form of CSS preprocessor. In the tutorial, I explain how to use the Sass preprocessing library as part of your Broccoli build pipeline to utilize Sass within your project and build CSS files out at the end. So let's go ahead and install Broccoli Sass source maps. Okay, great, that's installed. Now let's go ahead and move our CSS file into a Sass file. Great, that's done. And let's update our CSS, our Sass file with some actual Sass code in it. Okay, so what we're doing here is we're just defining a very simple Sass file. We're defining a body color variable. We're giving it the value pale green, and let's put a nice 5-pixel green border around our body. This is going to start looking really good. So after we've done that, we want to update our Broc file. Let's have a look and see what we're doing here. So we've got compile Sass, which has been required here. This package requires the Sass library to be passed to it. This allows you to use different versions of Sass with the plugin without having to use different versions of the plugin. So here we're including the compile Sass library, and let's go down here and have a look at how we use it. So first thing we want to do is we want to pass it in our app root, and we pass this in as an array, as this is what the compile Sass, the Broccoli Sass plugin requires. And it requires this because you can have multiple Sass files in multiple locations. And so Sass needs to know all the different locations where your files might be so it can resolve dependencies. The next option is we need to tell it what our entry file is. So this is relative to the application root. So this is our styles app SCSS file. And that's the first file that Sass is going to use to then start building your CSS. We're going to tell it what the output file is going to be, which is our assets/app.css. And we want to tell it to include source maps and the contents of the source maps. And we need these two options so that when we're developing in the browser, when we inspect a style, we'll be able to see our original Sass files rather than the compiled CSS file. So it makes debugging a little bit easier. And we're going to give this an annotation of Sass files. So let's go ahead and run this yarn build. Okay, great. So the slowest thing now is our Sass compilation. That's blown out of the water everything else. That's now taking 99 milliseconds. But that's kind of expected. Like Sass is a little bit intensive to build. So those other file copy operations where we're just copying an index file to the output directory, those are no longer the slowest things. Let's go have a look and see what's in our output directory. So within our dist directory now, we'll have a look in the assets folder and we can see we've got an app SCSS file and we've got a source map for this as well. So if we run this in the browser, good. We get our JavaScript alert and we can see it looks exactly the same as it previously did, except we've got a nice green border on it this time. So if we go ahead and inspect something on this page, let's have a look at the HTML. We can see we've got our background green, we've got our border, and you can see here that it says app.scss. So if we click on that, that's going to take us to the declaration in our Sass file rather than the CSS file. Now, if you imagine once you've got a really big project and loads of styles, it's much easier to be able to debug things if you can look at your Sass file rather than the compiled CSS output. Things get very, very difficult if you try and do that. So this is all looking good. Let's quit that and move on to the next stage. So ES6 transpilation. So what is ES6 transpilation? Well, we used to write JavaScript for JavaScript that could run in the browser. Then we started inventing newer JavaScript standards, and it takes browsers a little while to catch up and implement these new standards. But we as developers want to use the cutting edge new thing. So what we're doing here is we're going to be taking the new fancy ES6 syntax and have that converted to something that will actually run in the browser. And different browsers support different levels of the ES standard. So we're going to use a package called Babel, which will do this transformation for us. And Babel can actually write out different JavaScript files for different browsers if you want to as well. So you can go for evergreen browsers with one JavaScript file, and you can have like long-term support if you wanted to support, say, like IE10 in another file. So let's go ahead and install Babel. Great, so Babel's now installed. Let's go ahead and update our JS file with something that wouldn't typically run in a browser. So let's close some of these files up. So here we're using some ES6 syntax. And what this will allow us to do is have Babel convert this to something that will run in the browser. Now, some browsers will support some of this syntax and some browsers won't. But in order to get across the board support, what we're going to do is convert this back to ES5, which we know runs in all browsers and has done for many years. So the things that we've got here are const, This is a fairly newer part of the JavaScript language. And we've got these fat arrow functions where we're console logging out the message and we're console logging out this. Now in ES6, the fat arrow function works slightly differently to a regular function in that the context for what this is inherited from the parent scope. So in this case, when we look at this console log, we should expect it to be the foo function and not this set timeout. So we can validate that this is actually working correctly in the browser. So let's go ahead and update our build pipeline to now run things through Babel. Oops. So now, after you've updated your Broc file, we need to tell Babel how to work. By default, it won't do anything to your files. You need to tell it what versions of what browsers to support, so it knows how to convert your new ES6 syntax into your old ES5 or partial supported ES5, ES6 syntax. So what we're going to do here is we're going to create a .babelrc file. And within that, we're going to put this contents. So this is telling Babel some basic presets for when it passes your JavaScript files. So we're going to tell it that we want it to support the last 2 versions of every browser. And we also want to include this external helpers plugin. And this is just advised by Babel to include this. This, once we run it, should have our JavaScript converted from our ES6 into something that should work in at least the last 2 versions of every single browser. So let's go ahead and run a build. So now our project is built and we can see step 2 here that Babel is running. Let's go have a look and see what it's done. So we've got our input app.js file. Let's have a look at the output. That's odd. It doesn't seem to have changed it at all. Wonder why that is. Well, it turns out that since I wrote the tutorial, browsers have evolved and they now do support across the board the arrow function and the const keyword. So let's go ahead and put in some syntax that we know is not supported across the board. So we're opening up our app.js file here, and let's go ahead and put in here class foo. And let's see what happens when we build again. Let's have a look at the output file and see how things have changed. So we can see here that our class, our original foo class, has been converted into a backwards compatible function style class. So we can see that Babel has actually changed our source code into something that will run in the browser. Great, so let's continue on. Next up is ES6 module imports. So module imports are a newer feature to JavaScript and allow us to split our code into separate modules and use a build system to be able to pull those in at build time and remove the things that we don't need if we haven't used them. So let's go ahead and update some of our JavaScript to use the new ES6 module import. So first of all, let's create an app/foo.js with the following contents. And let's pop in a couple of exports in here. So in our foo.js, we've got a const named foo_named with just a value of foo_named, and we've got a default. So these are exporting 2 different properties. We've got a default and we've got a property called foo_name, a constant. Now let's update our app.js to import these things from foo.js. So here we can see we're importing, this is the default import from foo.js. So this value, this foo value will contain the value foo, the string foo. This value, foo_named, which is a named import that's coming from foo, will contain the value foo_named. And you can see here that we're console logging foo, and VS Code here is saying we're not using this, but the build pipeline doesn't know that we're not using that. Okay, so if we were to run this now, we would find we would get an error when trying to run it in the browser. And the reason for this is that Babel will work with these import statements within Node, but we want to run this in the browser. So in Node, they'll get converted to require statements, but those don't run in the browser unless we use something like require.js, and we don't want to do that. So let's go ahead and install a tool called Rollup, and we'll show you how this can actually work running in the browser. So first thing we want to do is we want to add Rollup. So this is going to install a few tools. It's going to install the Rollup package, the Broccoli plugin, and some plugins for Rollup itself. So we're now in plugins within plugins, but trust me, it'll work. And then we're going to want to remove the main Babel library itself because this is now included in one of the Rollup plugins. Cool, so those are uninstalled. Let's go ahead and update our Brock file to run the JavaScript through Rollup. Okay, so we're including Rollup here, and we are instantiating a new instance of the Rollup plugin here with these following options. So let me just give you a bit of background about what Rollup does. So Rollup is a module bundler, and what that means is it's able to traverse the dependency tree of your application following import statements and build up the dependency graph in memory. It will then convert all of that down into an output file or multiple output files if you want to chunk your output and do bundling across, say, different routes, for example, things like that. So it can create common bundles for things that are used between different parts of your application, and then it can bundle everything else into separate JavaScript files if you want to, or it can bundle everything into a final output file. One of the other things that it allows you to do is it allows you to do a function called tree shaking. Now what tree shaking does is it will dynamically detect through your code what it is and what isn't being used. So this foo named option here that we've imported from the foo package, it knows that that's not being used. In the same way that VS Code knows it's not being used, Rollup also knows. So it can actually delete that code. We never have to ship those bytes to the browser, and that's really cool. So if you're using a package like Lodash, for example, they have recently released an ES6 module version of that package. So rather than shipping every single function that exists as part of the Lodash library, you can just include the individual pieces that you want and only ship that code. This is great because it means there's less for the browser to parse, there's less for it to download. Users should be happy with that. So let's go ahead and run this and see what happens. And see what our app is going to build like. Yarn build. Okay, great. So we can see that our JS transformation now is taking the majority of the time, a half a second. Rollup has to do a bunch of stuff with your files, so it's going to take slightly longer for things to process. Let's have a look at the output JavaScript. Okay, cool. So what have we got here? Well, we've got an immediately invoked function expression, or an IFI, if you will, which is now wrapping our JavaScript. Now, if we look back at our JavaScript, we have an import for foo, and we've got an import for foo named, and we're console logging foo. So let's have a look and see how this corresponds to our output file. So we can see in our output file here, we've got a variable called foo, which has a string value of foo, and we're console logging it. Foo named is nowhere to be found. This is great. We've not only compiled something that will run in the browser, but we've also eliminated code that we just don't need anymore. So let's go ahead and run that and check this all makes sense. Okay. Great, we can see here, we're console logging foo. Rollup is working nicely. One other thing to point out with Rollup is that rather than using Babel on its own and Rollup on its own as part of our build configuration and shoving the output of Rollup into Babel or the output of Babel into Rollup, we can actually pass Babel to our Rollup configuration so that Babel itself, when it's running, knows how to do our Babel transformations. The reason this is important is because Babel is really good at working on small files and doing transformations between file A and file B. It's not so efficient at doing transformations on a really big file. The inverse is true for Rollup. So by using the two tools together, they can work in harmony, and everything should be much quicker than if we use them separately as part of the build pipeline itself. So we're nearly there with our full build pipeline. And when you're a developer, you want to try and save time. We don't want to have to keep reloading the browser every time we make a change. And something that you may be familiar with is using something that's called live reload. And this will automatically refresh the browser when we make changes to our source files. So I'm just going to click through to this. Okay. So stage 8 of the tutorial covers how to install and use live reload. So let's go ahead and install it. Oh, let's quit. Great, that's installed. Now let's update our Brock file. So the very last step here, we were previously returning this merge operation, which is our final output. But in order to know if any of those files have changed, we want to run that through live reload. And what this is going to allow us to do is, as part of the build pipeline, if any of the output files, whether it's a CSS file, a JavaScript file, the HTML file, if any of those things have changed, The live reload watcher will notify the browser to tell it what type of file has changed, and the browser can dynamically reload certain types of files. For example, if you change an image or if you change a CSS file, the browser can automatically just load those out without having to even refresh the page. If it's a JavaScript file or say an HTML file, the browser will just trigger a regular reload. So what we're doing here is we're assigning tree to a mutable variable here, and then we are reassigning it down here as we pass it into the live reload plugin. And finally, we're exporting the live reload plugin at the end. So the last step of our build pipeline is the live reload. So let's go ahead and run this and check everything works. Okay, server's up and running. So everything appears to be running, no errors. Let's move our browser to the side so that we can see as we're changing things, it should dynamically update within the browser. So let's go ahead here and change our border color from green to red. Look at that, updated automatically. Let's go ahead and change our background to blue. Awesome, this is working nicely. Now, what you don't notice is that this is happening in the background, the page isn't actually refreshing, but let's demonstrate that actually working. And you can see here, as we change our JavaScript file, the page is actually refreshed and our alert is now showing. Let's go and change our CSS file one more time. No alert. That means the browser didn't actually refresh itself. So this is great. We get a much faster feedback cycle. We don't have to wait for the browser to reload every time. This should be improving your workflow tenfold. Let's go and have a look back at our Brock file and summarize what we've learned. So we can see our Brock file has grown quite a bit. We're up to 60 lines. We've got various plugins that are being composed and passed into one another. At this point, you should have a basic understanding of how Broccoli is working and how different pieces connect together. You should be good to be able to take this further now on your own. You can follow along further in the tutorial and we'll cover things like asset hashing so that our assets have a unique identifier so that when we pass them to a CDN, they can automatically be invalidated as we upload new versions of those assets. How to debug a Broccoli tree and the tools that are available to do so. How to lint your files to make sure that they conform to your style guides and coding standards. How to do production and development builds with environment flags. And finally, how to minify your output files so that you compress them down to as small as possible. You may be familiar with minification or uglification as it's also called. And you can use this on both your JavaScript and your CSS files to make even smaller files that you're going to ship to the browser. So hopefully you enjoyed this tutorial. If you have any questions, feel free to hit me up on Twitter. I'm at Oli Griffiths. You can also check out the website. Hope you enjoyed, and thanks for watching.